Okay, let's go through lesson 3 wrap up. This is essentially like a quiz review in preparation for tomorrow's quiz. So we want to do several things here with each graph. This is what we've been talking about pretty much all year so far. Determine if each graph is a function by using our vertical line test. So let's go do that real quick. Letter A, it is a function. Passes the vertical line test. One more time, vertical line test. Drag a vertical line, your finger, your pencil across it vertically as long as it passes it at one point at a time. Function, function, and this is a function, okay? We are good to go. These are all functions. Next part, state the domain and the range. Okay, this is the part that I think will be a little funky. Domain and range. Domain is you focusing on the x-axis. Range is you focus on the y-axis. So we read a graph from left to right, and we want to figure out what x values are being used to make that graph and what y values are being used to make that graph. So we did this, I think, on, I think it was Monday or Tuesday. We started domain and range here. Okay, think of the domain as bookends. If there's a left and right bookend here, you're focusing on the x-axis for each one of these, okay? So I'm looking at the x's, and it looks like there could be, it stops here, but because that's an arrow at the top, it pushes through this wall, this bookend, and continues to open out, out, and out. And the same thing happens over here. It pushes through that wall, continues to open out, out, and out. So what that means then is it's continuing on to the left and to the right forever. So when we read this from left to right, we are using everything from negative infinity to positive infinity. Another way we can write this also is all real numbers. For the range, I'm looking at floors and ceilings. So I have a floor here, but I do not have a ceiling. It looks like it, but because I have arrows up there, it punches through there. So I have a floor. I want everything above -6 on the y-axis. So everything above -6 on the y-axis means y is greater than or equal to -6. And I use a equal to because this is solid down here at the minimum. That's why we get it or equal to. On the next one, letter B, the domain is the x's. So again, I don't have a wall here. I don't have this bookend. It continues past that. The domain's going to be everything. Negative infinity, positive infinity, or all real numbers. Okay. The range is where things usually kind of change up. I'm looking at floors and ceilings, and I have a floor right here. Sorry, I have a ceiling right here. I do not have a floor because it's continuing to open down on both the sides. So I want everything below that ceiling, everything below for the range of y is less than or equal to 1. Again, I use an equal to sign because right here at the maximum, that is a solid. Solids mean or equal to. Letter C, the domain is the same, meaning this arrow is punching through all the way to negative infinity, and this arrow up here tells it continue to open out forever and ever and ever. So here, the domain is also everything. Negative infinity, positive infinity, or again, the way to say this is all real numbers. The range is focused on the y's. I'm looking at floors and ceilings. And I don't have a ceiling here. The arrow is going to punch right through there, no ceiling. And I have a floor, but it's never going to actually cross the x-axis here. It's never going to cross y is 0. So we're going to put y is 0. We want everything above 0 right here on the y-axis. It never actually crosses it, so we're not going to use an equal to sign. It keeps getting closer, and that's something we're going to talk about throughout the year with an exponential. Letter D, with this graph. For the umpteenth time, the domain is everything from left to right or all real numbers, okay? Because those arrows tell me to do this, tell me to do that. That graph will continue going out. And the same thing is happening on the range. I have both a floor and a ceiling that are about to get erased because there is no floor or ceiling. Those arrows are going to continue to open out and down and up. So the range actually is the same thing, from negative infinity to positive infinity are also all real numbers. Now, the next piece says, label the type of graph as linear, quadratic, absolute value, or exponential. U-shaped graphs are quadratic. V-shaped graphs are absolute value. Curved shaped graphs are exponential. And lines are, well, linear. On each graph, label where it's increasing, decreasing, and constant. So we've been doing that now for a couple weeks. My eyes start left to right. It's decreasing here. It turns down there at the minimum and starts to increase. Letter B, my eyes are going up. It starts to increase. It turns and starts to decrease. On C, the only thing my eyes are doing, my eyes are increasing all throughout here, okay? So it's just increasing. And there is no max or min for an exponential. Letter D, my eyes are also going up. My eyes are increasing. So it's just increasing, doesn't turn or anything like that, and there is no max or min either on that. Determine if each graph has a vertical axis of symmetry, and if, okay, and we do. We took care of that. Okay, if so, draw it in. So does the graph have one? Yes, it does for this one. And where that vertical axis of symmetry is right down the middle, okay? So if you could cut right through there, the left folds onto the right, that's the vertical axis of symmetry. The absolute value has one. Excuse me. The absolute value has one as well. We took care of increasing, decreasing. There's my vertical axis of symmetry right down the middle of that. The left would fold onto the right. So yes, it does, and we drew it in. The exponential does not. There's no way to cut that. And then the linear does not have a vertical one as well. There's no way to draw a vertical line in here and get it to fold from left to right, okay? So, no. We took care of that. And if possible, show the absolute max or mins, which I kind of already talked about. This right down here is the minimum. This up here is a maximum. And the exponentials, there are none.